Okay. Hi, everyone. Today I'm going to be talking about real-world JavaScript security. So just a brief introduction. So I'm a security consultant at Software Integrity Group. Primarily interested in application security or secure programming. Big interest in programming languages, static analysis, and compilers. I have a Twitter. So before I start off the talk about real-world JavaScript security, I think it's probably best to just quickly have a brief overview of what the landscape looks like. Right? It runs everywhere, and it's being adopted at a very rapid scale. You can have browsers, servers, mobile, even IoT devices. And up ahead, I actually have an example of how you can do JavaScript wrong on Internet of Things devices. And there's a lot of frameworks, lots of abstractions, lots of complexity, especially when you're trying to build an application. I think if I look at any tutorial on hey, let's build this JavaScript application in 2019, it's like, okay, step one, npm install this thing. Before you've got Webpack, you've got even a basic React application. You've got all of these kind of things you have to understand before you can write some code. So there's a lot of high levels of abstractions, and they can sometimes go wrong. But what's even more interesting is that there's this move towards safe by default frameworks, and I'll expand on what I mean by this. So let's talk a little bit about client-side JavaScript frameworks. So if in 2019 or if you're building an application today, you're probably using React or Vue or the new Angular. And so by default, it has this concept of automatic escaping, where any user-supplied data that gets rendered in the browser gets automatically escaped. And you have some really interesting things here as well. You have explicit naming of dangerous APIs. So, for example, if you're using React, you have this concept of dangerously set inner HTML, whereas if you're using Angular, if you want to render something to the client, that should be rendered exactly as a string and not as an escape string. You have to explicitly go into your code and type in bypass security trust, or depending on which context you're sort of bypassing the trust on. And if you compare this to sort of applications a few years ago, when you were using things like jQuery, if you were creating a DOM node and taking user-supplied input and using jQuery, let's say you wanted to append something to the DOM, that API was actually dangerous because it wasn't doing any sort of sanitization or any output encoding. So, for example, let's say you had user-supplied input, aka I'm on your website, I sign up, and I say, okay, my name is script alert1 script, and you called append on that specific data, on that specific input, it would actually execute. It would execute code in your browser, which of course is a very bad thing. Just out of curiosity, how many people have heard of cross-site scripting? Okay, great. This is exactly okay. So, but yeah, so we're getting to this point where, okay, we have all these safe by default things, and everyone in the audience, or at least large majority in the audience, knows what cross-site scripting is. But there's still some edge cases, right? And this goes back to my point about JavaScript is everywhere. Turns out, if you play video games on Steam, the chat engine or the chat client is in JavaScript. In fact, it uses React in the bottom, and so. Sorry, it doesn't use React, but it handles URI schemes. And so what this guy did was he kind of looked at the React Steam client and figured out, actually, if I just type in a URL that's JavaScript, that's using the scheme JavaScript, I can execute code in the browser. I can execute code in the Steam chat client itself. And so there's still some edge cases. You can still kind of do this in React if you're in the latest version of React. There's a rule that would automatically lint to say, okay, hold on, you're rendering a link. Just be careful that you don't accept a protocol scheme that's not HTTPS, right? You should not really accept JavaScript URIs from arbitrary user data. And so, yeah, in this HackerOne report, it was an Electron application that, of course, that's what the chat engine is written in. And so it would take arbitrary URLs and it would execute it. But this talk, thankfully, because everyone knows about cross-site scripting, it's not going to be about cross-site scripting. And so my understanding, or at least in my day-to-day job, a lot of what I do is reviewing code for security defects. And so when I'm looking at a modern code base written in JavaScript or Node, if you're using a modern framework like React, and you're using CSP or maybe even TrustedTypes, which is this new specification that's that helps prevent DOM XSS bugs. XSS really is becoming less prevalent. You don't see it as much, and hopefully soon it should be eradicated. So this talk really is more about JavaScript security bugs I found. So a lot of concepts I'm going to demonstrate today are in Node.js, simply because it's a little bit easier to demonstrate these defects, but they also apply to the client-side code. And specifically, I want to focus on JavaScript-specific issues in terms of security rather than just generic. I don't want to come here and talk about SQL injection because probably most people know about it. So let's talk about some well-known bugs. We're going to talk about insecure object comparisons, prototype evolution, and mass assignment. And we're going to talk about a little bit about the ecosystem. So yeah, let's dig right into it. So up here, I was in an engagement last year, and I was reviewing this Internet of Things device. And what was really interesting is that this is a very low memory device, but the team decided actually because we want to rapidly develop this application, we're going to go ahead and use Node. And so again, the example is very simplified. It's supposed to be very terse, so I can. It's the spirit behind this example is really showing the spirit of the bug, right? And so let's dig into it. So up here we have this sessions object, and this sessions object was essentially this in-memory store that was used by the developers on this Internet of Things device. And then must be authenticated was this middleware. It was this middleware that would take a request response and a callback called next, right? After that, it would check, well, okay, if the request has cookies, great. Get me the token, the cookie that's called token. Make sure that token exists, and then make sure that token is inside sessions, the sessions object. And if it exists, and if it's inside my object, allow it. You're authenticated because it's something that I know. It's a secret that I know, and I'm comparing against it. Just out of curiosity, just a quick question for I guess the audience. Can anybody see what's wrong with this code? Yep, I think
you can just set the cookies.
You can just set the cookies.
Yeah, do whatever you want.
Not necessarily. Any other?
You can use expired sessions.
Not quite. Well, yes, but let's dig into what I'm trying to show here. Okay, so let's say sessions, the comparison. Let's say the attacker has sent this token and is called invalid string, right? When we run it through our middleware called must be authenticated, it returns false. Yep. If it's empty, it returns false. But something really interesting happens when the string is called constructor. Does anybody want to tell me why that might be? Okay.
Built-in JS.
Yep. Thank you, JavaScript. Yeah, it returns true. So without actually knowing what the session or the secret session might be, you can literally set your cookie to constructor or the keyword, the string constructor, and thanks to JavaScript.
I didn't hear the answer.
The answer?
Yes, he gave an answer, and I didn't hear it, and you said yes.
I'm sorry, I forgot that.
Repeat the answer. Why?
Why? Yes, we'll go into why. Okay, so let's go back to our code, right? Sessions as an object and must be authenticated as the middleware that checks, right? And when we see these things, we see, okay, invalid string, which obviously nobody should know, it's false. When it's empty, of course, it's false. But when the token is called constructor, it returns true. So let's take a look, right? So when you create an object in JavaScript, by default, it has these base properties, right? And so if you look at the prototype of an object, it has all these properties called constructor, has on property is proto, or and of course underscore proto. And this was really great when I found this. I went up to the client I was at. And I was like, hey, by the way, we have this authentication bypass. They were like, okay, let's go. And so let's have a demonstration in a bit. So yeah. If you look at the proto, you've got constructor, and of course, when you do this comparison, it returns true. And so the issue is really trivial to exploit. Let's go ahead and take a look at what this looks like. So the code I had on there wasn't the full code. So let's take a look at a real world example. So I've got Express in here, which is like the standard framework in Node.js for web applications. And we initialize our Express app. We use this cookie parser thing. And you know what? I've left this object just empty because it doesn't. It makes the bug more fun. And then we have this middleware, right? And this middleware is what's called when you go to the index, right? So if you don't know the cookie or if you don't have the token, right, it should say not authorized. And if you do have the token, it should say you made it. So let's go ahead and run this. So yep, we have this application saying it's returning not authorized. If I go into an inspect, and if I just say do something like this, if I say document.cookie equals token equals constructor, and if I refresh the page, woohoo, right? Thank you, JavaScript. And so yeah, it's fairly trivial to exploit these kind of issues. Now here I've really taken like an extreme edge case of where I've seen this issue. But really it exists in other parts of business logic. So you could be writing business logic that's just doing a check against an object. Because it turns out in JavaScript, the correct way to check against an object is to use this thing called hasOwnProperty, right? Because if I try and pass in the string constructor into hasOwnProperty, it's going to say, okay, hold on, no, that's false, right? But if you have the valid token, it will say, okay, I can see this thing exists in my object. But really, you shouldn't really be rolling your own authentication system. I see, especially if you're doing authentication in Node.js or server-side JavaScript, a good library to use is potentially a library like Passport. Or if you're rolling your own, there's lots of like common mistakes I see. The most upfront mistake I see is people just check against the token. And so a lot of times I've gone on sites and I've done like a timing attack simply because if you're doing just a generic check, it's not it's not constant time. So just by seeing the difference between the array comparisons when the chars are split, we can try and figure out what the valid token might be. And so there's lots of known common issues that can occur when you're trying to roll your own authentication. And so yeah, I mean this is the most general one I see, which is make sure if you're doing any sort of comparisons, make sure you're doing them in a timing safe, in a constant time manner, so that an attacker can't infer from the timing difference what kind of issue it might be. It also prevents timing attacks, of course. Up next, I want to talk about prototype pollution. So who's heard of prototype pollution? So I see lots of JavaScript developers. Now, prototype pollution, of course, is a bad thing, and it's always seen as this thing about quality, like, don't pollute the prototype. Actually, it also has security properties, right? So you can actually leverage prototype pollution to exploit applications. And this goes on to the bigger picture about how really, if you're looking at security defects, quite a lot of times they're actually quality defects too. So if you have any quality issues in your application, a lot of times if you let it go for too long, it can turn into a security issue. So for people who aren't familiar with how prototypes work in JavaScript, here's a quick example. So what I'm doing here is I'm taking the base object, the base type object, and I'm modifying its prototype to say that I'm adding this function called everywhere, and it takes an x and it returns x times 2. But now if I instantiate another object on line 2, I actually have this method on there, this function on this object called everywhere. And so this is going to be the case on every object, which is really interesting behavior. It allows you to do some really interesting things. but it can also lead to bad things. So yeah, of course, yeah, right, as always, don't the general advice if you're writing JavaScript is don't modify the base type's behavior. So let's take a look at how this how potentially we could exploit this, right? And so the requirements for this attack are something like this. You have an object, and you can control the first, second value, and also the first and second bits, and then the final value as well. So if you can, for example, control these bits, you can actually kind of trick the application into doing weird things. So here's the example. If I modify, and what's interesting here is that if I modify the prototype of A, it actually also ends up impacting another object because we're modifying the base prototype. So yeah, of course, but of course, nobody actually writes code like this, right? If you're seeing code like this, it's probably not great. But here's a real-world example. So let's take a look at this. We have an existing object, and then we have another object called some other object. And if you look at existing object, and if you take a look at the property attacker can control, it will say undefined, right? That's the standard behavior in JavaScript. And likewise with the other property as well, some other object attacker can control, it'll be undefined. But if you merge these properties, and if you merge these objects, and specifically if you do a deep merge, you can actually modify the prototype. So if input is coming in from outside, like let's say you're taking arbitrary JSON in your application, and then you're doing a deep merge on that object, you can actually kind of destroy the entire application. And we'll see how this works in action. So let's take a look. I've done this in a CTF kind of way. So let's take a look at the code here. So I have this server, and again, it's the same kind of code as before, but this time I have this post endpoint, right? And I've called it flag. I don't know how many. Is anybody here familiar with capture the flags? Okay, awesome. So yeah, I mean, if you want to get the flag here, all you got to do is set this has the answer property, right? And so what I've done here is that I've got this merge recursive package, which is actually a very vulnerable package. And I'll kind of get into why later on and how we can kind of prevent these kind of things. But yeah, it's trivial really. So what I've done here is we have a post endpoint called @/flag. It takes the JSON parser to parse JSON, and then it takes a request and provides a response. So we have this arbitrary user object. What we're doing here, really, the most dangerous part of this code is a simple merge, simple deep merge of objects, right? And in the spirit of making this example terse, I've just gone ahead and done this just to show like a proof of concept of this bug. And so if the user has the property, has the answer, it says you won. Otherwise, it says no. And let's take a look at this in action. So if I go to 1990, it will say, OK, cannot get. Yes, we need to go to flag. That's right. And so what I've done here is I've written this script called interact, which uses curl. And so all we're doing is we're posting this endpoint, and we're saying, hey, I have JSON. What happens? So if I run interact, it says nope. As expected, it's saying, OK, well, obviously, you haven't set this property. But if I go into exploit, and we see this, right? Now, if I pass in this prototype here and pass in this has an answer and just set it to an arbitrary value, we see something really interesting. It says you won. And so just by that, we've actually, as an outsider, coming into this application, we've actually modified the behavior of the application. What's even more interesting is that if I interact with it now, that property is still there, right? It's because you've modified the base value. So like anytime that object is now accessed with that property.
What's the implementation of the deep merge?
It's doing a nested merge. So typically, and I'll kind of go into the difference between a shallow merge and a deep merge up next. Yep. And so yeah, it's modified this property, and so now anytime this has the answer property is called, an attacker can control its behavior, and that's really scary in JavaScript. So yeah, this is what the exploit looks like. And so in the wild, if you look at it, there was a content management system called Ghost CMS. And I've left the link, and the slides will be available afterwards. And so the attack is in detail. This is how the attack goes. The attacker modifies this prototype of a property that he can control. And now, once you control a property in this big Node.js application, all you have to do is check somewhere where you can control it in a way to execute code. So let's say you have like some sort of script that's doing something dangerous, but of course, it's fine as long as there's no user input. Turns out in JavaScript, you can get user input from, well, almost anywhere if you can modify the prototype. So something that might be safe might now be unsafe simply because you've decided to do a deep merge instead of a shallow merge. And so how many people have used this like ES 2016 object spread syntax? Okay, cool. So everyone seems to be familiar with it. So yeah, and so you might say, actually, no, I'm using this object spread syntax, and that's fine, right? And so you might say, okay, I'm using this object, like this is so the object spread syntax is essentially the equivalent of doing object.assign and then passing in this other object, and so it kind of merges it. But this is different to what's called a deep merge, where you're taking not only the properties, but also the base properties of an object. And so you might say, okay, well, actually, I'm not going to be vulnerable to this. I'm using object spread syntax. And so, yeah, the difference here is that it doesn't take the underlying prototype or any other properties. For example, if you try and do something like this, it would not get copied because it only does a what's called a shallow copy. But let's take a look at this like registration functionality, right? So up here we have this controller that has this register endpoint. And this register endpoint takes a request, and what it does is that when a request comes in, it just takes the body of the request and it goes ahead and saves it into the thing. And if you look at the registration form on the client side, you have this action that posts to /register. It has a username and a password. Everything good so far? Okay. But if you look at the schema or the database model, and this is what the schema looks like, right? This is a typical, like, I think this is the Mongo schema object that I'm using, and it provides, like the password and the username as a string. And this is good so far. But what happens when another developer makes a change? So, I think especially with all of our requirements changing so constantly, with this, especially with the whole, if you're doing CI/CD, you're making changes almost daily, and you're deploying to production. 6 months later, there's a new requirement now, and the project manager goes to you and he says, "We need other information about the user, right? We need their email. Username's not really going to do us. We need to track them. We need their location. We also need different kind of user roles." And yeah, sure, go ahead. Let's go ahead and update the code. And this is, again, from a real-world example. This is something I did a code review 6 months earlier. It seemed fine. I go in 6 months later. I'm looking at the code. And I see, okay, there's some new functionality. Let's take a look. And so now we're doing something like this. We've created another model, and we were just taking user roles, and we're passing it in to the schema. Probably not the best way to model your code, but let's go with it. But now we have an issue, because if you remember the code from earlier, we're just taking any arbitrary data supplied in from the request body. And so due to the lack of explicit whitelisting of properties, an attacker can simply set another property on the code. So going back to our objects, let's take a look at how this could potentially work. So this is an issue called mass assignment. And so if I go into here, we have the server, and let's take a look at the authentication model. What if our model looks something like this, right? I've gone ahead and we need different user roles, and we need a user role called admin. And when you have this user role called admin, we've gone ahead and added this. But if I look at the code, but if we go ahead and look at the application from a thing, let's go ahead and register and see what the application looks like from the outside. Right? We have this registration endpoint, test user, test. And if you take a look at the network, we see this registration endpoint. It goes ahead and just goes ahead and just does this, sends this to the server. And let's log out. Actually, let's take a look at this again. If we inspect this this form, we see there's actually only two inputs. Right? We have this username input and this password input. But of course, this was fine 6 months ago, right? But now we have other properties, and so let's take a look at what this looks like in the database. So let's take a look at Mongo. And so if I take a look at this, we've got this test user, and we've got the password in clear in clear text, very bad. And then we have this is admin property set to false, because if we look at the code, if we look at the code, we're defaulting it to false. Can anybody think of how this could potentially be exploited? Yeah, and so one attack called mass assignment is essentially doing something like this. If we go into network and if we do another, let's say another second user, second test, submit this, and if we take a look at this request and then copy it, if I copy it as a curl request, if I paste it, what I can do as an attacker is something as easy as this. I can simply create another user, devox, and then what I can do is I can pass in this another property. I can say is admin is true. And so this attack is what's called a mass assignment attack. And so we've got the success. And if I go into Mongo, and so we can see actually, despite the user not knowing, or despite the request in the form, despite the rendered HTML not having this property, an attacker can simply, possibly guess the names of other properties that might be that might exist on the server. And so you have to be very careful with this. So the correct way to write this code, this pattern is actually very bad. To just take arbitrary structure, and especially when you're working with things like Mongo, this thing could also apply to any other database implementation, because really the bug here is that you're allowing users to post any property that exists on your model. And so yeah, what you need to do here is really make sure you whitelist. So yeah, the best workaround for this kind of bug, and I see this very frequently in sort of Node.js and JavaScript applications, but the same concept also applies to Java or C#. If you're using entity framework in C#, it's the same thing. You have to do these whitelisting things. This bug actually in the real world was actually exploited against GitHub. This is a few years ago, but yeah, in GitHub it was exploited, and so it actually led to a change in the Rails core, this active record thing, which manages the database implementation in Rails. It led to a change there to make sure actually that users are doing some sort of whitelisting. And especially if you're using Mongoose, which is this driver for MongoDB in Node.js, there's actually a package called Mongoose Mass Assignment that helps prevent against exactly this kind of bug. So that really covers a lot of my the bugs I want to talk about in terms of implementation. Up next, I want to talk about like third-party components. How many people are actually writing Node on a day-to-day basis here? Okay, we see a few hands. Okay, and what about client-side JavaScript? Front end. Okay, cool. And how many people are using third-party packages? Yeah. Okay, great. And so, yeah, I mean, you have to make sure you keep these packages up to date. One quick way, really, it's built into NPM itself, is NPM audit. You can just go ahead and just use NPM audit to find and figure out, like, are there any known vulnerable components in my application? And so what's really interesting nowadays is that even if you do NPM install, if you're installing an older version or a known vulnerable version of a package, it will tell you, like, hey, by the way, FYI, please go ahead and check this. And you can actually put this in your CI. You can really have some sort of checks to make sure, because it's so simple to do. And what's even better is that there's also NPM audit fix. Let's say there's a minor release of the package that's vulnerable. It will automatically upgrade that package for you, because most of the packages in the NPM ecosystem use semantic versioning, and so it can do those kind of things where it can say, okay, hold on, this is vulnerable. Let's go ahead and fix this. And then I guess, and then I have some final thoughts. One of the best things, I think, especially I work with a lot of development teams that are pushing out software on a regular basis. Code review is really important. And what I mean by that is it can be both automated and sort of manual code review. So if you're doing pull requests, code review, you should check it not just for quality purposes, but also for actually, does this modify any of the security impact on my application? Measure and track your code quality and security, because actually it turns out a lot of the teams I've worked with, and especially a lot of the teams that our organization works with, if you're not tracking your quality or your security metrics, you won't know if you're actually making a difference or if you're improving. And so I see a lot of teams use things like SonarQube, but actually if your SonarQube has like 5,000 issues open, you're not using it right. And of course, this is always a really hard thing, because if you already have this like big code base and it's been worked on for a few years, and then you add things like open source management tools like SonarQube and or some commercial tools, it's really hard, because you straight away you're applying all these set of rules to code that didn't quite conform to this set of rules. So you could look at it as technical debt, but best way to measure, and actually doing this kind of measuring is better than not doing anything at all. But even better is automating the process. Make sure you're using linting tools. This is straightforward. It's very easy to use. Hook it up in your CI. Make sure your code base is conforming to these rules. It makes your code review easier. It makes your development process easier, and increases the quality of your code. You should never really ignore these these warnings or errors given to you by these tools. And of course, there's also various static analysis tools available on the market for both quality and security. And if you're interested, we have a booth downstairs. This is something that Synopsys offers as well. And finally, if you really want to get mature, you should go ahead and start breaking your CI builds if any issues are flagged by the tool. And that kind of covers it up, really. Are there any questions? Anyone at all? Yep, we have a question. Nope. Okay. Okay. Awesome. Thank you very much, guys.